So now we're going to be talking about solving systems of linear equations. There's two main methods that you can use to solve these systems of linear equations. One is called graphically. That's when you actually graph both the linear relations on the same grid, see where they cross. That would be the point of intersection, and you'd be done. The other method is called algebraically. And algebraically, there's two main methods that we're going to be talking about with the algebraic method. One method is called substitution, and the second method is called elimination. In this video here, we're going to focus on substitution. But before we get to that, I want to talk about this idea of solving something graphically. Graphical solutions work. However, let's take a look at this example here to kind of discuss it. Let's say I've got a line here. Let's continue this line this way. If we're in a situation where we go to graph our two linear equations and they cross at a point much like this one, that's not a big deal, right? That's easy to determine, right? This point here in this case would be -1, -2, -2, -3, -4. This would be -4, 1. So, fairly easily, if I can graph both linear relations, I can quickly find the point of intersection. This point of intersection crosses with integer values, and it's good, right? Now, if instead, let's say this is my line 1, this is my line 2, instead, let's say we have another line going this way, and now the point of intersection, if you take a look between, I'll label this line 3. If we're interested in finding the point of intersection of line 3 and line 2, you'll notice now they don't cross at an integer value. So there's no way that you can give a accurate answer as to where these two lines cross. So your answer is now estimated value. So the limitations of solving something graphically is that everything's fine as long as the point of intersection is at integer values. This is commonly not the case. For most solutions, those two lines are going to cross at non-integer values, in which case you need the algebraic method. So with the algebraic method, like I said, there's two different techniques we're going to be using. One is called substitution, and the other is called elimination. Okay, so let's take a look at this idea of substitution. So the technique of substitution is useful when you have a system of linear relations where one of the coefficients in front is a 1 or a -1. So in this example here, if you take a look, I've got two different equations. Here's equation 1, here's equation 2. I want to find its point of intersection, right? So we want to find the point of intersection for this system. I want to find where these lines cross. Well, using the method of substitution, what you do is you pick a variable and you pick an equation that has a 1 in front as one of its coefficients. So if I go to equation 1 here, I can either choose to isolate for the x or isolate for the y. So step 1 here, we're going to isolate for x in 1. So I'm going to choose to take equation 1 and I'm going to isolate for x. Well, if I isolate for x in 1, we get x equals -2 plus y. So notice here I've isolated for x in equation 1. Okay, what's step 2 for solving using substitution? Well, I'm going to sub x equals -2 plus y into the opposite equation that you're working with. So I was working with equation 1. I isolated x for equation 1. I'm going to substitute that into equation 2. So now everywhere you see an x, you're going to replace that with a -2 plus y. Notice here when I did my substitution, I did brackets. And that's very important that you do brackets around that. So when I distribute my 2 here, now we're going to take our 2, distribute it into the brackets here. When I go ahead and do that, we get -4 plus 2y minus 7y is 11. Now we're going to collect like terms. So if I collect up my like terms here, I have 2y minus 7y is -5y minus 4 is 11. And now you just have a basic equation to solve, right? Add 4 to both sides. You get 15. And solving for y, I get y is minus 3. Okay, so just to recap where we're at before we finish this off, is you first pick a variable to isolate for. You're looking for the equation. You're trying to find a coefficient of a 1 or minus 1. I saw the 1 for the x, so I isolated for x and 1, subbed it into equation 2. Everywhere I see an x, I change it to a negative 2 plus y, solve for y. And now that you solve for y, you can sub this y value into either equation 1 or 2, it doesn't matter, and solve for x. I'm going to sub it into 1, it doesn't make a difference. This will be x minus negative 3 equals negative 2. X plus 3 is negative 2, in which case x is negative 5. Okay, so putting this all together here, the point of intersection, these two lines cross at negative 5, negative 3. And you can have your point of intersection. So this is the method of substitution. Let's try some more here. Okay, notice you don't always have to use x's and y's here. You can use any letters. In this case, they use m and n's. Again, you want to find the equation and the variable that has a 1 in front, or a minus 1. In which case, it's going to be my equation 2 and my m. So what am I going to do? I'm going to isolate for m in equation 2. So therefore, if I do that, you get negative 6 minus 2n. Okay, now I'm going to substitute m equals negative 6 minus 2n. I'm going to substitute that into equation 1. So everywhere I see an m, I'm going to change that to a negative 6 minus 2n. And then I'm going to go ahead and do my distribution. And we get negative 12 minus 4n plus 5n is negative 18. And then we're going to collect like terms here. So collect up my n's. I get n minus 12 is negative 18. N is negative 18 plus 12. N is negative 6 here. So I solve for my n value. And then we're going to go back up here. And again, like I was saying, you can solve for, you can sub this n into either equation 1 or 2, it doesn't matter, and you'll get your answer. So I'm going to sub my n value, which is negative 6. I know this time I'll sub it into equation 2. So it's going to be m plus 2. It's not an n anymore. It's a negative 6. And you get m minus 12 is negative 6. M is negative 6 plus 12. And m is positive 6. So therefore, my point of intersection here is going to be 6, negative 6. Now notice here, a lot of times people have trouble with this. When you create your point of intersection, you're going to do it by alphabetical. So it's going to go m and n. Just as the previous question went x and y, you go by it. You order the points, the coordinates, by the alphabetical order by the letter. So in this case here, m and n, and the previous one we had x and y. Okay, so let's take a look at the third example here. So again, I want to solve this using substitution. So I'm trying to find an equation that has a 1 in front as a coefficient. If you take a look here, I can see equation 2, there's an x with a coefficient of 1 in front. So I'm going to isolate for x in 2, in which case I get x equals 2y plus 11. And I'm going to sub x equals 2y plus 11. I'm going to sub that into equation 1. So everywhere I see an x, I'm going to change that to a 2y plus 11. So if you take a look at my equation 1, get rid of that x, change it to a 2y plus 11. Go ahead and do my distribution. I get 6y plus 33 plus y is 5. in which case here we get 7y plus 33 is 5. Subtract 33 on both sides. You get 7y equals 5 minus 33 is negative 28. Divide by 7, and we get y equals negative 4. So my y value comes out to be negative 4. Now again, I found my y value. I can sub it into either equation and solve for x. I'm going to go ahead and isolate, and I'm going to sub that into equation 2. So I'm going to sub y equals negative 4 into equation 2. You get x minus 2 times negative 4 is 11. X plus 8 is 11. X is minus 3. Okay, so putting this together here, we have our final answer. The point of intersection is negative 3 and negative 4. Okay, now notice here, I just want to point this out here. Every single one of these answers that we have gotten here can be checked. So for example here, we had discovered that the answer for the first question was negative 5, negative 3. We can check that into this equation, making sure it is in fact correct here. So let's take a look here. Just going to get this out of the way. Let's go ahead and actually try to see whether that is the case. So I want to see whether my answer here, this negative 5, negative 3, I want to ensure that's actually is the answer to this question. Well, what you do is you go to equation 1 and do a left side, right side check. So everywhere I see an x, I'm going to change that to a negative 5, and everywhere I see a y, I'm going to change that to a minus 3. And I want to see, does this equal negative 2? Well, this becomes negative 5 plus 3, and negative 2 equals negative 2. So in this case here, the point negative 5, negative 3 satisfies equation 1. Likewise, you go to equation 2, and it has to satisfy equation 2 as well. So everywhere I see an x, I change it to a negative 5. And everywhere I see a y, I change it to a negative 3. And I want to see, does this equal 11? Well, this will be negative 3 plus 21. Does that equal 11? Negative 10 plus 21 is 11. So doing a quick check here, I have my point negative 5, negative 3. It satisfies equation 1. It satisfies equation 2. Therefore, I know that this is the point of intersection for this system here. And likewise, you can do that for example 2 here and example 3. Okay, so this is solving a system of linear equations using the technique of substitution. Thank you.